Hello everyone. So in today's session we will solve some numerical problems based on cylindrical wave functions. So the first question is that we need to show psi equals to log rho e to the power minus jkz is a solution to the scalar Helmholtz equation. Also we need to determine the Tm and Te fields generated by this psi. Okay, so to start with we have psi equals to log of rho e to the power minus j k z. So this is the psi function that has been provided in the question. So at first what we need to show that this psi is a solution to the Helmholtz, it satisfies the scalar Helmholtz equation. Okay. So we will find out del square psi upon del z square plus k square psi. So we will perform the derivation with respect to z. So it will be del z of, so first is del psi del z. So we will differentiate this psi function with respect to z first. Okay. So on differentiating we will, on this log rho will be log rho and e to the power minus j k z will be e to the power minus j k z for complete differentiation. We are having minus j k, okay, plus k square psi. So this will give us, again we need to perform with respect to z. So it will be, we will have here log of rho to the power minus j k z, one more, minus j k plus k square psi. So this is 0. Hence psi satisfies the scalar Helmholtz equation. Okay. Now what? Now the question says like we need to determine the Tm and Te fields generated by this psi. Okay. So to start with, we will start for the Tm case first. So for Tm case, we can obtain the fields Tm to z by letting, so to start with we can write like, we can obtain the fields Tm to z by letting A as UZ psi. Okay. Now, in cylindrical coordinates, we will find the fields as okay. So, we will start with, we have A equals to UZ psi. So, we know H will be curl of A. Okay. Now, we will find out curl of A in cylindrical coordinates. Okay. So, we will have curl of A equals to 1 upon rho, and then we need to perform the curl operation. So, this is A rho, it will be rho A phi, this will be A z. Now, del del rho, del del phi, del del z, and this will be 0 0, and this is psi. So, we will have therefore, we can write curl of A as 1 upon rho, and then A rho, this will be del psi del phi plus rho A phi minus of del psi del rho plus A z 0. Okay. That is, we are left with 1 upon rho, this will be A rho del psi del phi plus rho A phi minus of del psi del rho. Since H is curl of A, so now we can write the fields as, therefore, H of rho will be 1 upon rho del psi del phi, okay. Then H of phi will be minus of del psi upon del rho, and Hz will be 0. Okay. So, let us denote these equations as equation number 1, this is 2, and this is 3. Now, for the E fields, we will write E as 1 upon y cap del of del dot A minus of z cap A. Now, we can write del dot A as, in cylindrical coordinates, 1 upon rho del del rho of rho A rho plus 1 upon rho del of A phi upon del phi plus del of Az upon del Z. So, for this case we are left with, so this will be 0, and so we are left with del of psi upon del Z. Okay. Therefore, we can write del of del dot A as A rho del rho plus A phi del phi plus Az del Z, and here we have del psi del Z. So, we will get A rho cap, this will be have del square psi upon del rho del Z plus A phi cap 1 upon rho del square psi del phi del Z plus Az cap del square psi upon del Z square. Now, we will substitute this and then find out the E fields. So, we will get E rho as 1 upon y cap del square psi upon del rho del Z, E phi as 1 upon y cap 1 upon rho del square psi del rho del Z, and then we will have Ez as 1 upon y cap del square psi upon del Z square minus Z cap psi. So, this we can write it down as 1 upon y cap del square upon del Z square plus k square psi. Okay. So, these are the E rho, E phi and Ez fields. Okay. So, okay. So, this will denote this as 4, this as 5 and this as equation 6. Okay. Now, in the question we have psi as log of rho e to the power minus j k z. Okay. So, we will have E rho as 1 upon y cap del square psi upon del rho del Z, that we derived previously. Okay. So, now we will substitute this psi in these places. So, 1 upon y cap, this will be del rho, at first differentiating with respect to Z. So, this will be log of rho and we will have here as e to the power minus j k z minus j k. Okay. Now we will differentiate with respect to rho. So, we will have del rho of log rho as 1 upon rho and minus of j k e to the power minus j k z. So, this is equation 7. Now, we will have E phi. So, E phi we know is given by 1 upon y cap 1 upon rho del square xi upon del phi del z. So, we will write it like 1 upon y cap 1 upon rho, and then first we will differentiate with respect to z and then with phi. So, we will have, when we differentiate with respect to z, we will have log of rho e to the power minus j k z minus of j k and then on differentiating with phi the term gets 0. So, we have E phi as 0. So, this is equation number 8. Now, for E z. So, E z we can write E z as 1 upon y cap del square del z square plus k square psi. So, we can write it like this: y cap del square del z square psi plus 1 upon y cap k square psi. So, again 1 upon y cap. So, this on first differentiation we will get del z of, this will be log of rho e to the power minus j k z minus of j k plus 1 upon y cap k square psi. Now, again differentiating with respect to z, we will have 1 upon y cap, this will have as log of rho e to the power minus j k z, again 1 minus j k. So, minus j k multiplied by minus j k, we will get minus of k square plus 1 upon y cap k square psi. So, this we can write it like 1 upon y cap, this is minus of, so this and this will get cancelled and we will have zero. So, basically this term gets as 0. So, Ez is also 0. So, give this equation number as equation number 9. Now, H rho, H phi and H z. So, H rho we derived it as 1 upon rho del psi del phi. So, differentiating psi with respect to 0 will give us 0. So, this is equation number 10. Now, h of h phi. So, h phi we derived as minus of del psi upon del rho. So, minus of del rho of psi was log of rho e to the power minus j k z. So, it comes as minus 1 upon rho e to the power minus j k z. So, this is equation number 11 and hz was 0. So, these are the fields for TM case. Now, for TE. Okay. Similarly, for TE case, we can obtain the field TE to Z by considering, okay, so start with TE case. So, for TE case, we can obtain the fields similarly by letting F as UZ psi. Okay. So, we know we can write E as minus curl of F and H as 1 upon Z cap del of del dot F minus y cap F. So, in the similar pattern we will find out the fields for the TE case. So, we will start from finding out curl of F. So, we can write curl of F as 1 upon rho, this is A rho, rho A phi, A z, this is del rho, del phi, del z, this is 0, 0 and xi. So, this will give us 1 upon rho A rho del psi upon del phi plus rho A phi minus of del psi upon del rho plus Az 0. Therefore, since E was minus of curl of F, so we can write the fields as E rho as minus of 1 upon rho del psi del phi. E phi we can write as minus of curl of F. So, minus of minus, this will become plus. So, this will be del psi upon del rho and then Ez is 0. So, let us denote this number as 13, this as equation number 14 and this is equation number 15. Next, for H we will find out 1 upon Z cap del of del dot F minus y cap f. So, del of f we will have similarly 1 upon rho del rho of rho a rho plus 1 upon rho del of a phi upon del phi plus del az upon del z. This we obtain as del psi upon del z. So, therefore, del of del dot f we will get a rho del rho plus a phi 1 upon rho del phi plus az del z and then del psi del z. This will give us a rho del square xi upon del rho del z plus a phi 1 upon rho del square xi del phi del z plus a z cap del square xi del z square. Okay. So, we will find h rho as 1 upon z cap del square xi del rho del z. H phi we will get 1 upon z cap 1 upon rho del square xi del phi del z, and hz we will have 1 upon z cap del square xi upon del z square minus y cap xi. This we can write down in the form as 1 upon z cap del square del z square plus k square xi. So, let us denote these equations as equation number 16, this as 17 and this as equation 18. Okay. Now, in the given question, psi was log of rho e to the power minus j k z. So, we will have e rho as 1 minus of 1 upon rho del psi del phi. This will be with respect to phi, if we differentiate we will have 0. Then e phi we have del psi upon del rho. So, it will be del rho of log rho e to the power minus j k z. So, we will get, so del rho of log rho, it will be 1 upon rho e to the power minus j k z, and then we had E z as 0. So, let us denote this as an equation 19, 20 and this as 21. Now, the h fields. So, h we have h rho as 1 upon z cap del square xi upon del rho del z. So, it will have 1 upon z cap. So, this will be del rho. So, first differentiating psi with respect to z. So, we will get log of rho e to the power minus j k z minus of j k. That will give us 1 upon z cap. So, again with respect to rho, so log rho we will have 1 upon rho e to the power minus j k z minus of j k. So, we have 1 upon z cap minus of j k upon rho e to the power minus j k z. Okay. So, this is H rho. We will give it as equation number 22. Then we will find out H phi. So, H phi is 1 upon z cap 1 upon rho del square xi upon del phi del z. So, we will have H phi as 1 upon z cap 1 upon rho del phi of log rho e to the power minus j k z minus j k. So, this will be 0. Okay. So, H phi is also 0. So, this is equation 23. Now, Hz. Okay. So, Hz is 1 upon z cap del square upon del z square plus k square xi. This we had. Okay. Now, we will substitute xi. So, we will get, so first we separate this del square xi del z square plus 1 upon z cap k square xi. So, we will have this 1 upon z cap del z of log of rho e to the power minus j k z minus of j k plus 1 upon z cap k square xi. So, we will see that this is also coming as 0. So, this is equation number 24. So, these are the fields, like these are the TE and TM fields that are generated by this xi function. Okay. So, this is all for now. Thank you so much.